Travis Gillespie. And in the last video, you learned how to find values using graphs, and then, values of a function using graphs, and then actually check to see if that function held true. Let's move forward and look at a real life application here. And right here we have the function y equals 7.5x describes the number of inches a beetle can travel in x seconds. Graph the function. Use the graph to estimate how many inches a beetle can travel in 2.5 seconds. Well, if I were graphing this function, which I already did and set it up, the first thing I would do is create a table as we did before, and create x values or values for my domain, and solve for y, and come up with some ordered pairs, and then I'd take those ordered pairs and throw them up on a graph, which that is what I've done. So this is what the graph of 7 and 5/10 times x looks like, or what 7.5 x looks like. And notice the label on the graph, or both labels. On my x-axis represents time in seconds, and my y-axis represents distance, the distance that a beetle travels in inches. Let's go ahead and analyze the graph and what the distance would be if the beetle traveled 2 inches. So if I just come over here and say, all right, I'm at 2 seconds, and I may have just said 2 inches a second ago. Basically, restating the question here is, what distance will the beetle travel after 2 seconds? Rather than 2 inches, 2 seconds. Okay, so moving to 2 seconds and scrolling up along, and I finally hit the graph here, the line, and I see that, hey, this line is somewhere between 12 and 18 seconds, and if I move across, it's pretty much right in between. So the beetle will travel 15 inches in 2 seconds. Also, if I took 7.5 and multiplied it by 2 for x, I would end up with y equals 15, which makes sense. So this holds true so far. And also, what will that distance be if the beetle travels for 4 seconds? Well, scroll back up. You see that the distance in inches is 30 inches in 4 seconds. But the question's not asking us to do that. The question is saying, hey, use the graph to estimate how many inches a beetle can travel in 2.5 seconds. So, well, 2.5, 2 and 5/10, 2.5 seconds, really. So what I'm doing here is going right down the middle and just moving up my chart and seeing that, hey, this looks to be like around 2.5 inches. Well, 18 seconds is here, so about 2.5 seconds. I keep saying inches for time, and I apologize, but let me look. I'm gonna cheat a little bit and use my line tool as an extra ruler to say, hey, we cross at 2.5 seconds where our y meets up with 2.5 seconds is just a little bit above 18, and you can see that right there is where it crosses a little bit above 18 inches. Now I'm just reversing distance and time altogether. So pay attention to when you are actually analyzing a graph to those both x and y axis as you read them. So at 2.5 seconds, the beetle, have traveled just a little above 18 inches. If I were to do the math here and check my function, then I'm hoping that my y value is going to be a little bit greater than 18 inches. So I'm going to just change the color here. We'll work it out real quick. Say, okay, well, y equals 7.5x, or for x here, you'll have 2.5, and 7.5 times 2.5, that equals 18.75 inches. So yes, this does hold true. It checks out. So in this entire section, you've learned to graph functions, to analyze the graphs, and those functions to the graphs, and also interpret, in this example, interpret the inches a beetle can travel in a certain amount of seconds. Neat.